Good evening. Welcome to another YouTube class, Success Camp. Today we shall be learning about dimensional analysis. And then dimensional analysis has importance. Why do we do dimensional analysis? Why do we do dimensional analysis in physics? We have 4 reasons written down for us so that in order to save our time. Number 1 is to check the correctness of a physical relation or formula. Number 2, to convert the value of a physical quantity from one system to another. Number 3 is to derive relation between various physical quantities. And number 4, to find the dimensions of dimensional constants. In order not to waste time, I will be talking about the first one. We'll be checking why dimensional analysis is important, and then by doing that I'll be working with the first one, which is to check the correctness of a physical relation. So I'll be using the equations of motion, which is v equals to u plus at. The next one, which is s is equals to ut plus half at square, and the third one, which is v square equals to u square plus 2as. So when we are checking the correctness of any of a formula, it means that whatever we have on the left hand side must be equal to what we have on the right hand side. Whatever I have here must be equal to what I will have here. It does not matter, even if I have L, it means if I have L squared here, I must have L squared here also. I must not have L raised to power minus 2. No, it is not correct that way. It means that I'm not having the same thing. Though I may have L squared and I may have 2L squared, it's still the same thing. We may not really work with this. But what we're interested in is the letter and the power that is being raised to. They must have the same power that is being raised to. So without wasting time, let's move. So the first one, which is v equals to u plus 8, and my v is velocity. So in order not to waste time, I'll just move straight to the dimension of velocity. Remember that velocity is meter per second, and meter per second is lt minus 1 in dimension. U will be what? lt minus 1 also, because they are both velocity, and my acceleration will be lt minus 2, because it's twice velocity, times t, which is dimension for time. So to continue, we have lt minus 1 equals to lt minus 1 plus L. Remember that in indices, when you have two bases multiplying each other, you will add the powers. So minus 2 plus 1 is minus 1. So lt minus 1 equals to 2lt minus 1, and that is how we got this. So this is correct. Now we are moving to the second one. So s is equals to ut plus half 8 square. So the SI unit of this is speed, and the SI unit is meter. SI unit of velocity is meter per second. I just purposely want to write the SI unit in case you have forgotten. And the SI unit of time is seconds, plus half acceleration. SI unit of acceleration in meter per second square times s square seconds. So now let me move to the dimension. Dimension of meter is length. Dimension of meter per second square is length per time minus 1. So lt minus 1 time t plus half lt minus 2 times t squared. So this way we are having L is equals to L. Don't forget that in indices, when you're having the same base multiplying each other, you will add their power. So let me say there is a 1 here. Minus 1 plus 1 means 0, so these cancel each other. then we have plus half L. So when we the same base, minus 2 plus 2 give me 0. So well, I can actually say, since they're giving me 0, I can say t raised power 0 half L t raised power 0. L is equals to L. Anything raised power 0 is 1 plus half. Anything raised power 0 is 1. So L is equals to L plus half L. We cannot leave our answer like this, so we know when time we have a fraction, we need to find the LCM. So L is, the LCM of this will be 2, and this is, I can put a 1 here, just 1 into is 2, 2 times L, 2L plus 2 into 1, 1 times L. So L is 3L plus 3L over 2, and this is also correct, just like the first one was also correct. So if you look at it, we have just L here and we have just L here. I told you the other time that you should not mind the number that are in front, you should only mind the number that are being raised to. And L here is not raised to any power, this one is not raised to any power, so that makes it dimensionally correct. The last one, which is v square equals to u square plus 2as. So I'll just move straight to the dimension so that I don't waste time. Dimension of v squared is lt minus 1, because it's a v square, so you just squared everything, equals to lt minus 1 square it plus 2 lt minus 2 times, and what is my distance? L. Sorry. So my LT minus, so if I open this bracket, I'll be having 2 times L, that is L squared, and then this, the same thing, L squared t minus 2 plus 2L, okay, times this L, give me square t minus 2. You'll notice that the thing is almost looking like now. L squared t minus 2 equals to, since they're the same thing, just add everything. That give me 3 L squared 2 minus, so this makes it also dimensionally correct. And that is that for today's class. God bless you for joining. Please, if you have not subscribed, click the notification button below and subscribe. Goodbye.